divide by their atomic mass. For carbon it is 12, nitrogen it is how much it took for nitrogen?
What?
The
The mass of
atomic
nitrogen?
mass,
Atomic mass of nitrogen was
14, right?
14. Yeah.
So that was divided by 14. And hydrogen, the atomic mass, Aisha, is 1. So you get the number of moles. These are moles. Moles are obtained when you divide the given mass by molar mass. Okay, and you divide. So whatever the moles you are getting, divide all the moles by the lowest number of moles. So divide all of the numbers by 1.26. So here you got 5, this you got, because you are dividing by 1.26, so here you got 1 and this 5, right? So this means carbon has 5 atoms, nitrogen has just 1 atom. This is hydrogen has 5 atoms and nitrogen is 1. Okay, this is one you don't write actually. So this is going to be the formula, empirical formula of the compound. Okay, empirical formula gives you the ratio of number of atoms. It doesn't give you the actual number of atoms, right? So this I hope is clear to all of you.
Yes.
Yeah.
Now we need to get the actual number of atoms. So actual formula is going to, you to get the actual formula, you need to multiply to a certain whole number, that is n, and you get the formula as C5n. Okay, but n you don't know, H5n, and nitrogen is n. Similarly, the same thing you can do it for the mass also. The empirical formula mass into n times will give you the molar mass of the compound. So molar mass of the compound is given. Aisha, you can see this is 240. And what is the empirical formula mass, Noha? Tell me. What is it?
Really, 12 into 5
C5
plus
H5n, yeah, 12 into 5 is 60, 60 plus 5, 65, 65 and 14. Got it? It is going to be 79 into n. 79 times n is 240. Is that clear? So what is the value of n coming out to?
3.
Yes. It is approximately, you can treat it as, because actually you are not getting the whole number. Got it?
Yes.
Right, Aisha? So, but if you figure it out, 80 into 3. Okay, it is very close to 80. So you need to round off to get the actual answer. So it is 3. So what is the empirical formula? There's a C5H5n, and the actual formula is C15H is 15, 5 into 3, and nitrogen is 3. So that's very good that both of you answered very well. And Ma asked me whatever was not clear to her. That's good. Any other question which
Yeah.
need to be answered?
For the third one, the molecular mass is not given. Right?
That you need to calculate.
Yeah. So for that,
the
what I
theoretical.
did was the empirical formula I found out was, and then it was ferric oxide, and then for the mass I found out it was 160 into n. So for the molecular
Yeah.
mass, I don't know what
So
to
here,
put. So I just,
yeah. This is not related to empirical formula at all.
well, it
Okay.
says to
What
find
you
the
can,
molecular formula, right?
yeah, you need to, yeah, it is actually not the molecular formula is given, copper sulfate. So this is the mass related problem, that how much mass of copper is present in 100 gram of copper.
Not
So
that
Aisha,
one.
Which one? The third one?
The below one. Yeah, the third one.
Okay, the molecular formula of iron oxide in which the mass percentage of iron and oxygen. Yeah, how you did it? This is a FeO or Fe2O3 or Fe3O4.
I got it as ferric oxide, Fe2O3.
Yeah, then it is okay. Fe2O3 is an ore of iron that exists.
Yeah, after finding the simplest ratio and everything, the empirical formula, I've got the ferric oxide. So, but then
Yeah.
to find the molecular formula, you need the molecular mass too, right? So for that, I just kept it at 160 only. And then I got N as 1. And then the
Yeah,
molecular formula is
in actually ionic compound, normally you don't give the molecular formula because there are hundreds of molecules. You give just the empirical formula in ionic compound.
So what should we do then?
No, you consider that as the final answer. Take it as a final answer.
What, the ferric oxide?
Yeah.
Okay.
Suppose NaCl is there. So this is Na plus and Cl minus. Okay, this is not the actual molecular formula because if you take the NaCl, there are going to be many Na and many Cl. So in normally in ionic compound, you don't actual formula. There can be many atoms. Okay, many ions, many cations, many anions. Okay, but you in ionic compounds, you mention the empirical formula as their formula. Got it?
Okay.
Clear? So what you got is correct. So this, Aisha, any other doubt you are having?
No.
Any other doubt? Anything which is
No.
not clear? Okay. Now you can just try on your own also. If there is still there is problem, Aisha and Ma, you can ask me. Okay.
Okay.
Don't hesitate. Discuss with me whatever the problem is. Okay. Let's move on to the next topic. What we were doing yesterday, we were doing day before yesterday, we were doing concentration terms, right? So concentration terms we were doing. We did the mass percentage. Mass percentage is actually the mass of a substance present in 100 grams. How much is present in 100 grams?
Yeah,
So
we
how we
did that.
how we are going to find it? That I told you, mass
Get a
of is
formula and stuff.
divided by total mass, okay, upon 100, right? That we discussed. Okay. And we discussed mass by volume percentage. We were about to discuss what it is. It is also written like this. Mass by volume percentage. So how to find it out and what it means? It is used when you mix a solid in water or in solution. Suppose you mix a sugar in water. So how much percentage of sugar, how many grams of sugar is present per 100 ml? Per 100 ml. That is called W by V percent. Percent means out of 100. Out of 100 what? Volume. So per 100 ml, how much amount of sugar is present or whatever you are mixing, that is called mass by volume percentage of the compound. For example, suppose if you have 10%, you need to see that whether it is W by W written. If it is W by W, it is the previous one, mass percentage. Means total mass, the mass of a substance divided by total mass. And if it is W by V, this is mass by volume percentage. Okay, so 10% mass by volume percentage of sugar solution. So in a layman language, it means 10 grams sugar is present in 100 ml of solution. Total solution 100 ml, and out of it 10 grams is actually put in. But suppose if I take 50 ml solution, I will have 5 grams. But in order to describe, I describe it with respect to 100 ml. That's the percentage. But it doesn't mean that always, Aisha, you are going to have 100 ml, because solution can be 50 ml. It can be 10 ml also. So you can accordingly calculate as per the given amount. But whatever is mentioned, that is for 100 ml. Suppose if I ask you how much is there in the 50 ml, you just half it, you will say 5 gram of sugar is present in 50 ml of solution. Is that clear?
Yeah.
Yes.
And suppose if somebody asks me how much is there in 200 ml, so just double it. Apply the unitary method. In 100 ml, you are having 10 gram. In 1 ml, you are having 10 by 100. So in x gram, you are having x ml, you are having this much sugar. Okay, so this is used when you dissolve. This concentration term is used when you dissolve, when you put solid in a solution, in a liquid. Is it clear?
Yeah.
Yes.
So the definition you should need to be very clear in school. So an amount of solid present in 100 ml of solution. Okay, a denominator must be 100. That's the definition. Next is suppose that is V by V percentage. That is also same. V by V percentage. It is volume by volume percentage. It is used when you mix two liquids. Volume by volume percentage means out of 100 ml, by volume, how many mLs of there are there of a particular substance. Okay, how many mLs of a particular substance ml or liter, whatever the unit you are taking, continue to do that. Of a particular substance of, let's say, A. Present in total 100 ml of solution of A and B. Got it?
Yeah.
For example, 5 ml methanol. Both are liquid, both are expressed in ml. What is the volume percentage of methanol? You added 5 ml to 15 ml of pure water. Got it?
Yes.
Okay.
So just apply the formula and tell me. That how much we are going to get, right? So volume of ethanol divided by total volume, and we assume that the total volume is additive. It has not changed much. Okay. So volume of ethanol is And I shall keep the unit same. If you are taking ml in the numerator, keep the units ml in the denominator also. Got it?
Yes.
Yeah.
Volume of methanol and plus volume of water in ml. And this will be 20 ml, but you want to find it in 100 ml, so multiply it by 100, and that will be percentage. Got it? So how we can get the answer? 5 divided by 5 plus 15 into 100 percent, and 5 by 20. So it is
So it's
actually
25%.
25% to mention V by V. Okay, volume by volume. Okay.
Okay.
So percentage means out of 100. Percentage by mass means out of 100 gram. How many grams of a particular substance are there? Volume percentage means out of 100 ml. What is the percentage? What is the percentage by volume of a particular component? Okay. And now we will move on to part per million or billion. ppm. It means parts per million. Have you heard of it, both of you?
No.
Parts per million. Parts per million is actually, suppose if something is present in very less amount and you can't detect in 100 parts, so you take large amount, million parts or million parts. Million is 10 to the power 6. Okay, so that is called parts per million. Example, in the water which we drink, if they contain some poisonous substances, heavy metals, but they are very, 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 very less. Okay, otherwise they will harm us. Very, very, very less amount they are there. So their concentration cannot be. It will be insignificant if you consider in percentage. You will not get any percentage, 0%. Okay. But if you take a very large amount, because they are not there, so sometimes you will find due to some external factors or impurity getting mixed into the water, and they are very present in very less amount. So you need to calculate them in the billion liters or billion grams. What the point? Or million liters or million grams. So ppm or ppb is about that only.
Okay.
ppb is parts per billion. Billion is 10 to the power 9 and billion is 10 to the power 6. Normally ppm is used. So suppose if you want a substance ppm, A in the mixture. So how you are going to calculate the formula? That is mass of A. Keep the unit same. Divided by total mass of the solution or the mixture. This is for 1 gram. Okay, when you divide it by total, that is for 1 gram. And for million gram, it is 10 to the power 6. You can count the ppm with respect to ml also. So this is ppm by mass and ppm by volume. So ppm means when you are going to use it when something is present in a very less amount, it is so less that it can't be detected in terms of percentage. Then you use a large amount, more amount of the sample, that is million parts, 10 to the power 6 parts, or billion part, 10 to the power 9 parts. If you are using ppm, multiply by 10 to the power 6, ppb multiply by 10 to the power 9. Okay, so mass of A divide mass of the substance whose ppm you are calculating divided by the total mass. If the volumes are given, volume of the given substance in ml or liter, whatever is given, keep the unit same in the numerator and the denominator, divided by the total volume into 10 to the power 6 if it is ppm, or 10 to the power 9 if it is ppb. Got it?
Yes.
Let's take one
Yes.
example. Okay, uh, we have we use toothpaste in the morning, all of us use, right? And it contains fluoride. A lot of fluorides are there in it. Fluoride up to some extent, little bit amount is good for us. It can prevent the cavity. Okay, but large amount is harmful for our bones. So toothpaste contains fluoride. Little bit fluoride is there. So it's because it is small quantity. So its quantity is measured in ppm. Got it? So let's do a question on that only. So this is ppm. Normally we find the ppm from the mass divided by total mass into 10 to the power 6. But this is a
Okay.
reverse question. This is a reverse question. ppm is already given. Okay. But I am asking a different thing. Find the mass of fluoride in so you have a big tube that is of 200 grams. So that 200 gram bigger tube you take off the Colgate or something. At how much fluoride is present in it, that you need to discuss. So Aisha, have you understood the problem?
Yes.
Okay, use this formula.
Sir, I'm getting 0.2
What's the unit? And Aisha, what you are getting?
grams, right? 0.2.
Hmm. So we have ppm given. Yeah, Aisha. How much?
I'm getting the same answer.
Okay. So in place of ppm, you are going to write the ppm value. Okay. So what am I going to write? 1000 ppm. Mass of fluoride in grams. This is not known. Let it be m. Divide by the total mass of the sample, that is 200 grams. Because it is parts per million, you need to multiply it by 10 to the power 6. So 3 zeros will cancel from where? 2 zeros will cancel from where? You are going to get 1, 10 to the power 1, and that is n equal to 2 divided by 10. M is mass of fluoride. Got it?
Yes.
And if mass is not given, volume is given. For gases, generally volume is given. So for them also you can calculate. It is volume. It is ppm with respect to volume. So you write the volume of the component, divide by total volume.
So what
Okay.
unit we have to use for that?
Pardon?
What unit do we have to use for the volume?
Volume ml. Okay. Make sure, or you can use the
Okay.
liter also. Make sure that in the numerator you have the volume of the component, and denominator you need to have the total volume in the same unit which you have used in the numerator. Okay. Divide them and multiply
Okay.
by 10 to the power 6, and that will give you the ppm by with respect to volume. Ppm can be with respect to mass if you take mass by mass, and ppm can be with respect to volume. Okay.
Okay.
Let's move on to mole fraction. It is represented by a symbol which looks like X. It is a Greek symbol which is known as chi. Okay, it is represented by X. Mole fraction. As the name indicates, it gives the fraction of moles of a component from the total mass.
So what do you mean by the fraction of the mole?
Fraction means out of 1. Like suppose it is like this. This is pizza you are having. And if you take this much, so how much you took? You took 1/4.
Yeah.
Got it? Out of the 4 parts, you took 1. So 1/4. So fraction is always going to be less than 1.
Oh, so
Out
basically
of
the decimal.
yeah,
Okay.
yeah, exactly. Or you will get the answer in the decimal 0.25. Got it? So
Yeah.
gives us the fraction of moles of a component. So out of the total mole, how many moles are there for a particular component? Okay, that is called fraction. So fraction, how you are going to find out? Suppose if you have a mixture of A plus B plus C, or it could be D also, you can extend the formula. So mole fraction of A means where Na is the number of moles of A. So mole fraction of A means out of the total moles, what fraction of moles is possessed by A. So you will take Na upon Na plus Nb plus Nc. Is that clear?
Yeah.
Similarly, Aisha xb will be the mole fraction of B. And what you're going to write, moles of B divided by total moles. Got it?
Yes.
Mole fraction of C Maha will be how much? How to calculate?
Basically, NC by the sum of the moles of all.
Yeah, Na plus Nb plus Nc. Suppose if you add all the fractions, different types of fractions, if you add them, what you will get? When you add all the fractions, sum of the mole fractions will be equal to one. Okay, fractions when they get added 1 by 4, 3 by 4, okay, you will get 1. So sum of the mole fractions of all the components will be equal to 1. This sigma represents the sum. This is in short form I have mentioned. Okay. So if you have two components, if you have mole fraction of one as 3 by 4, what will be the mole fraction of the other component? 1 minus 3 by 4, that will be 1 by 4.
Yeah.
So if you have mole fraction of just one is missing, you can find it out by subtracting the mole fraction of rest of the components from one. Okay. So let's do a very simple question. For example, I take 4 grams of hydrogen and 4 grams of helium are mixed together. You need to tell me the mole fraction of hydrogen. Aisha, we are given with the mass, okay, not the moles. So now you need to find the moles first. Then only you can find the fraction with the help of moles.
Yeah.
So first step is find the moles. Moles of hydrogen. Moles you can calculate from the mass.
So
Always remember.
for hydrogen, it's 2 mole, and then for helium, it's 1 mole.
Yeah, and moles. What formula you are going to apply? Given mass by molar mass.
Molar mass.
So given mass is 4 grams of hydrogen, and molar mass of hydrogen, because there are 2 atoms in hydrogen gas, so 1 plus 1 2 gram per mole. So 2 moles. Yes, exactly. And Aisha, what is the number of moles of helium we can try? Number of moles of helium will be equal to mass of helium divided by the molar mass of helium. Helium, the molar mass is
4 only.
4.
4.
Yeah. If it is atom, just a single atom, it is 4U. If it is mole for complete group, it is 4 gram. Got it? The figure remains the same, 4. It becomes U. If you have just one atom, it becomes gram. If it is for one. Got it? So
Yes.
you took one. Aisha, is it clear? Any doubts up to this point?
No.
You found out the moles. Right. Now the mole fraction of hydrogen. That will be moles of hydrogen. Moles of hydrogen. Moles of hydrogen. That is 2 by 3.
2 by 3 mole.
2 by 3 is 0.67. 66. So we can write it at 0.6. And the mole fraction of helium is going to be 1 by 3. 1 divided by 1 plus 2. That is 1 by 3. Or just
So
subtract
is it
it
a
from 1 to
must to convert it into decimal form?
No, not necessary. You can leave them as it is. Sometimes it is
Okay.
more comfortable to use fractions. Okay. So this is mole fraction is clear. Very simple. So
Yes.
can you tell me, Aisha and Ma, can you tell me the units of mole fraction?
I mean, mole only, right? Mole, since it's in fraction, so raised to -1. The power will be negative.
What are the units of mole fraction? So in the numerator, you also are having a mole. In the denominator, you are also having moles. Okay. So mole by mole, that they get cancelled. So it is unitless. Similarly, that mass percentage, mass of a component divided by total mass, that is also unitless. Got it?
Yes.
Okay.
These are unitless quantities. Because whatever you are having in the numerator, you are having the same thing in the denominator. So except W by V percentage. W by V percentage was mass per 100 ml. That was gram per ml. Got it? But W by W, V by V, volume by volume, numerator you have volume, denominator you have volume. So it is going to be a unitless quantity. Okay?
Yeah.
Is that clear? So this is a common question. And next we move on to a very important units unit of concentration term, and that is represented by capital M. It is known as molarity. Its formula is very simple. Molarity equal to number of moles divided by volume of the solution in liters. Very simple. So per liter, how many moles are dissolved? Suppose you are having a 5-liter solution, so you divide the total moles by 5, so per liter you are having. Got it?
Yes.
And its unit is mole per liter, or it can be represented by M also.
Okay.
We can write the definition. Dissolved in 1 liter of complete solution, or 1 liter of solution. Per liter of solution. You can write that. Number of moles of a component present in 1 liter of solution. For
Okay.
example, if I take 5 molar HCl solution, what it means in layman terms, 5 molar HCl means 5 moles of HCl are present in 1 liter. Got it?
Okay.
For example, 2 molar NaOH, or sometimes it is written, even the class 12 student get confused and they keep on asking me what it is. This is M by 10. Okay, M by 10, it, it is nothing but 1 upon 10 molar. Got it?
Yes.
Okay.
Means it is 0.1. 1 by 10 is how much? 0.1 mole.
Yeah.
NaOH mixed in
1 liter.
1. Is that clear?
Yeah.
Got it? So very simple. If the mass is given, convert them to moles. Then, if the volume is given in ml, divide it by 1000 to get it in liters. Okay. Now, moles by volume in liter will give you the molarity of a solution. Is it clear or not?
Yeah.
The unit is mole per liter, right?
Yeah.
Molarity, you can write one statement. It can fluctuate. It can change with temperature. Very important point, will be useful for your class 12th also, all the examinations which you are giving. Molarity can change. It can vary with temperature, Aisha.
Okay.
Because if you heat a solution, the volume expands. The same moles are there in the more volume. If you cool down a solution, the volume comes down. That same mole, it becomes more concentrated little bit. So molarity can change with the temperature. It is a drawback of molarity. They ask you that what is the drawback of molarity? It can change with temperature. Or which concentration term can change with temperature? Wherever you have volume, that can change with temperature. Mass cannot change with temperature. Where moles cannot change with temperature. Wherever you have the volume, just remember, wherever you have the volume, all those concentration terms can change with temperature. Got it? Do remember this, a very, very important point for questions in CBSE as well as in competitive examination. Right? So
Okay.
let me end today's class. Just revise your